Okay, Chapter 1-6, Practice Exercises A, 10 through 24 all. Here are the answers. This is actually even answers. Please go ahead and check them. You can pause this video and check your answers and make sure that you have case 1 and case 2 where it's necessary, and make sure that you've checked your answers. On the next slide, I have went ahead and I have written down all of the answers that you'll need for 1-6 inequalities. Here are all the answers to those also. By all means, please hit pause on this video, and then you can go ahead and check your answers for that also later. Tonight's homework is Chapter 1-6, Practice A and Practice B, 26 through 36 even, and 58 through 66 even. Be sure that you are checking your answers, okay? So here we go with today's lesson. Today's lesson is Chapter 1-6, Absolute Value Inequalities. And it's very similar to absolute value equations, except for now we're dealing with inequalities. And inequality is always dealing with a region of answers. And that's what we're going to be talking about today, is finding the region of answers that allows this inequality, more specifically the absolute value inequality, to be a true statement. Now, yesterday we talked about equations. And when we dealt with absolute value equations, we always had case 1 and we always had a case 2. Now today, we're going to be dealing with inequalities. We're going to be doing the exact same concept, except for this time, we're going to be dealing with an inequality statement. An inequality statement, what you have to remember here is when you're doing an inequality, you have to remember to flip the sign when you multiply or divide by a negative number. That is extremely important. When you multiply or divide by a negative number, you must flip the sign. While we do this, we are going to simply pretend that the inequality symbol is actually an equal sign. That's what we're going to pretend today about, okay? Still have to have case 1, you still have to have a case 2, okay? So here we go. Steps in solving absolute value inequalities. Step 1, isolate the absolute value. I cannot tell you enough how important this is. Isolate your absolute value. Get rid of the addition and subtraction before or after the absolute value symbol first. After you do that, then you can get rid of any multiplication attached to it, okay? Determine if the absolute value is even possible. Remember, we talked about this. Look to make sure for common sense things. Look for, can a positive ever be less than a negative? Well, no, a positive can't be less than a negative. If a positive is less than a negative, then that's never a true statement, so we don't have a solution there. We still have case 1 and we still have case 2. In this case, what I want you to look for, I want you to look for the and symbol. The and symbols are all your less than. And the other ones I want you to look for are your or statements, which are always going to be your greater thans. Okay? Your and statements or your compound inequalities are going to be your less than symbols. And then your ors are going to be your greater than symbols. And you're still going to solve each case, and you're going to do the number lines, and you're going to find your final answer. The number lines, I will say, are optional. It's something that does help you to think about what you're doing. When you're doing an and, if you recognize that it's an and statement and it's a compound inequality, then you don't have to do the number lines, and you'll know already what the answer is. And then you are done. Final answer. Now, when you are solving an inequality with the less than symbol, then this is an and statement. And we know that the and statements have an overlapping graph, okay? A compound inequality, that's an and, looks like something like this. -3 is less than x, which is less than or equal to 4. That's a compound inequality, something that looks like this where x is trapped. That's a compound inequality. That's an and statement. Okay? Now, an or statement is going to be used whenever it's greater than. An or statement is used with the greater than symbol. And you must have case 1 and case 2 with this. Okay? You must have case 1 and case 2 with this. Okay, here we go. Let's start some of these problems together. I'm going to do the odds. No, I'm not going to do your homework with you because I want you to understand how to do your homework. If I do your homework for you, then you're not going to redo it. So, number 25, this is the problem that we have. 3 times the absolute value of y minus 9 is less than 27. Now, this is going to be a less than statement. Would you agree with me? With the less than statement, this means that I have an and compound inequality. That means x is trapped. Okay? What we're going to do first is we are going to isolate this absolute value. So tell me, does 3 go into 27? And the answer to that is yes, it does. So if I divide both sides by 3, I'm going to get y minus 9. Did I divide by a negative? No, I did not. Is less than a 9. Because this is a compound inequality, if I would pretend that this is an equal sign, what we would have going on here is case 1. First of all, is this possible? This is a positive outcome, and that's going to be less than a positive outcome. That's possible. 3 is less than 5. 10 is less than 22. Those are both positive numbers, so this is a possible scenario. So case 1 would be y minus 9 is less than 9. And case 2 would be y minus 9, a negative in front of that, is less than 9. Now, if I were to take case 2 and divide this by -1, what would you do? This means that you would flip this inequality symbol and I'd have a -9 there. Now, the beautiful thing about a compound inequality is notice that what they have in common here is this y minus 9. So since they're the same, I can put y minus 9 here in the middle, and I can put is less than 9 here, and I can say, the arrow is pointing to the -9 there, is less than -9 over there. Yes? So -9 is less than y minus 9, which is less than 9. I can do that every time, and then I have my compound inequality. All I have to do is add 9 to all sides. And I'm going to have 0 is less than y, which is less than 18. And there's your answer. Okay? And there's your answer. And that was all because it was a less than symbol. So let's do this again. Same exact problem, but if I would have done this problem right from the beginning, recognizing that this is going to be a lovely little and, I could have said, okay, well, I'm going to have -27 is less than 3, parenthesis, y minus 9, parenthesis, less than 27. So the question I have for you is, how would you solve that? Well, what you would do is you would distribute that. Yes? Then what would you do? You would add 27 to both sides. This goes away. I'm left with 0 is less than 3y. That goes away is less than a 54. And then you divide the left by 3, the middle by 3, and the right by 3. 0 is less than y, which is less than 18. Okay? And you're done. That's your answer. How do I graph that answer? Here's a 0, here's an 18. They're both open, and y is in the middle. Let's go to 28. 28. Let's first look at the symbol. The symbol says it's less than. So since it's a less than symbol, this means it's a compound inequality. Before I do anything, I'm going to go ahead and first isolate this. So here's my absolute value. What am I going to do to isolate my absolute value first? I'm going to subtract 2. So I have 1/4. Absolute value of x minus 3 is less than a -1. How do I get rid of the 1/4? Well, this 1/4, I need to get rid of that by multiplying by 4 on both sides. So this goes away, and I'm left with the absolute value of x minus 3. Did I multiply by a negative? I did not, so I keep my sign, is less than -4. Well, now, I've isolated my absolute value. I recognize that it's an and, okay? So this would be a compound inequality, but before I do case 1 and case 2, I need to first check to see if this is possible. So the outcome for my absolute value is going to be a positive outcome, and that's going to be less than a negative outcome. Well, can that ever happen? The answer to that is a positive can never be less than a negative, so this is going to be no solution. Done. Because that's never possible. That is never possible. Okay? Again, number 30. This is going to be less than or equal to, which again is an and compound inequality. So I'm going to first isolate my absolute value. So I have to get rid of that plus 9. So I'm going to subtract 9 from both sides. That gives me 3 times the absolute value of 5t minus 1 is less than or equal to. Well, what does 23 take away 9? Well, the answer to that is going to be 14. Now, technically speaking, I still need to get rid of this 3. But guess what? 14 is not divisible by 3, is it? Since 14 is not divisible by 3, I'm actually going to leave it alone because I don't want to deal with a fraction since I already have whole numbers there. So my question is this possible? I'm going to take a positive outcome and I'm going to multiply it by, what is the outcome of an absolute value? The outcome of an absolute value is positive, and that has to be less than or equal to a positive outcome. So a positive times a positive is a positive, and that means a positive has to be less than or equal to a positive. Is this possible? The answer to that is yes, it is possible. So since this is an and, I'm going to put a negative of 14 over here. Why? Because that's where this 14 comes from over here on the right. And I'm going to have less than or equal to 3 parenthesis 5t minus 1 close parenthesis is less than or equal to 14. And what would you do? You would distribute. So negative 14 is less than or equal to 15t minus 3 is less than or equal to 14. Okay, at this point, what would you guys do? At this point, what we need to do is go ahead and then add 3 to the left, the middle, and to the right. So if I add 3 to the left, to the middle, and to the right, negative 14 plus 3 gives me negative 11, is less than or equal to 15t. That goes away, is less than or equal to 17. Now I need to divide my left, my middle, and my right by 15. And I have negative 11 over 15 is less than or equal to t, which is less than or equal to 17 over 15. What does the graph of this thing look like? A negative 11 over 15 goes here. A 17 over 15 goes to the right. They are both closed, and since it's an and that means it's trapped, t is in the middle. Okay, so I've done 3 compound and inequalities. So if you go to the next one, what you're going to notice is that this next problem, which is number 66, is a greater than problem. And if you remember in the previous slide, I said greater than means it's an or statement. What do or graphs look like? Or graphs go in opposite directions. Which means we still need to obey the rules. So we still want to go ahead and isolate this. So how do I isolate this? By adding 3 to both sides. So I have x plus 5 over 3 is greater than 9. Absolute value bars, sorry about that. Now, I need to see if this is possible. So the outcome of an absolute value is a positive, and that's going to be greater than the outcome of this 9, which is positive. Can a positive number be greater than another positive number? Well, absolutely. 1 million is definitely greater than $100, right? So in this case, I can go ahead and do case 1. X plus 5 over 3 is greater than 9. And case 2, negative parenthesis x plus 5 over 3 is greater than 9. So I'm going to multiply by 3 on this side and this side, and I have x plus 5 is greater than, I did not multiply by a negative, 27. I subtract 5, and I have x is greater than 22. Over here, I'm going to go ahead and divide by -1. Why? Because I can. So when I divided by a -1, what happened to my inequality symbol? It flipped that sign to give me is less than -9. Now, how do I get rid of that 3? I multiply by 3. And I have x plus 5 is less than -27. How do I get rid of the 5? I subtract it. And I have x is now less than -32. So now, since this is an OR statement, what that means I need to do is I need to go ahead and put them on one number line. My smallest number is -32. It's open and I shade to the left. And at 22, it's to the right of -32 and it's open and I shade to the right. But I need to make sure that I'm reading this from left to right. So that means x is less than -32 or x is greater than 22. This is my answer. Okay? And I can do one more problem where it's greater than so that you guys can understand this a little bit better. And I'll be super nice. I'll even do a homework problem. This is going to be 62. So this is going to be the absolute value of -2x plus 1 is greater than 2. So it's already isolated. So what I need to do is I need to look at my inequality statement. My inequality is a greater than symbol, so since that's a greater than symbol, greater than means it's an OR, which means my graphs go in opposite directions again. Yes? So since I'm already isolated, I go straight to case 1. -2x plus 1 is greater than 2. I forgot. Is it possible? What's the outcome of this going to be? Positive. And can a positive be greater than a positive? Yes. So case 2. -2x plus 1 is greater than 2. So I subtract the 1. -2x is greater than 1. I divide by -2. And x is greater than? I think not. We divided by a negative, so we must flip the sign. Is less than -1/2. Then I go to case 2, and I need to solve case 2. So I'm going to distribute this. So that gives me 2x minus 1 is greater than 2. Add the 1. 2x is greater than 3. Divide by 2. X is greater than 3/2. I do not need to flip the sign there because I did not divide by a negative. So now I need to put these on one number line together. My smaller value is -1/2. That is going to be open, and I shade down to the left. My other value is 3/2. That's going to be open, and I shade up to the right. So putting these from left to right, my smaller value is x is less than -1/2, or x is greater than 3/2. This is my answer. Okay, guys, I have talked to you about your ORs and your ANDs. They're all compound inequalities here that we're talking about. You know what tonight's homework is. Just to make sure that you know what it is, tonight's homework is 26 through 36 even and 58 through 66 even. And this is going to be on page 46 and 47 on your textbook. Okay, and whenever I say check your answers, I mean check your answers on this page right here in the video. Okay, I will see you guys on Monday. Have a great day.